Hello there, and welcome to The Sleepless Scientist, a quiet place in the cosmos where your thoughts can slowly unwind and knowledge becomes something soft enough to rest beside for a while. Tonight's journey will take us into one of the strangest and most intimate mysteries in the universe, consciousness itself. Before you settle in too deeply, I'd love it if you could take a gentle moment to like the video and subscribe. Only if these quiet little explorations truly help you relax or drift into sleep. And if you feel like it, leave a comment telling me where in the world you're listening from and what time it is for you right now. Maybe it's a rainy midnight in London, a warm evening in Brazil, or an early morning somewhere quiet in the mountains where the world still hasn't fully woken up yet. Now, feel free to dim the lights. Maybe pull the blanket a little closer. Perhaps let a fan hum softly somewhere in the background, and together let's slowly wander into the mystery of consciousness. And if your mind begins drifting halfway through, that's perfectly all right. In some ways, drifting is part of the story tonight. Take a moment and notice something very simple. You are aware, not just awake. Not just breathing, but aware. There is something inside your experience that feels present, a quiet sense that you're here, listening, existing behind your thoughts. Right now, sounds arrive in your ears. Maybe you can feel the weight of your body against the bed or chair beneath you. Perhaps there's a faint memory from earlier today still floating around somewhere in your mind. An unfinished conversation, the taste of coffee, the feeling of sunlight on your skin from hours ago, and somehow all of those things are being experienced by something, by you. That might sound obvious at first, almost too obvious to notice, but the more carefully you look at it, the stranger it becomes. Because what exactly is this you that experiences anything at all? Your body is made of ordinary matter, carbon, oxygen, hydrogen, atoms forged long ago inside ancient stars. Your brain is a biological organ weighing only a few pounds, soft and electrical and remarkably fragile. Tiny cells exchange chemical signals, electrical pulses flicker through neural pathways, proteins fold and unfold inside microscopic structures smaller than dust, and yet somehow, from all of this unconscious matter, comes experience. Not just information processing, not just reactions, but the feeling of being alive, the redness of a sunset, the sting of embarrassment, the warmth of nostalgia, the strange heaviness of sadness late at night when the world becomes quiet and your thoughts suddenly grow louder. Science can describe the mechanics of many things. It can explain how stars form, how black holes bend space, how gravity pulls galaxies together across unimaginable distances. But consciousness is different. Consciousness is the one mystery we cannot step outside of to examine completely, because every examination already happens inside it. It is the lens through which every other mystery is seen. And perhaps that is why people have struggled with it for thousands of years. Ancient philosophers wondered whether consciousness came from the soul, from divine breath, from some hidden spiritual essence placed gently inside the human body. Others imagined it as a flame, fragile but sacred, flickering behind the eyes like candlelight behind a paper window. Even now, with the modern neuroscience and brain scanners and advanced computers, the mystery remains strangely unfinished. We can watch the brain working. We can see electrical patterns shifting during dreams and waking states. We can observe different regions becoming active when someone remembers a face, hears music, or falls asleep under anesthesia. We can even predict certain decisions seconds before a person consciously becomes aware of making them, and yet, none of that fully explains why experience exists in the first place. Why does the universe feel like anything from the inside? A computer can process information, it can recognize voices, it can answer questions, it can even imitate emotion surprisingly well. But does it feel loneliness? Does it experience the colour blue? Does it know what warmth feels like on a cold winter morning? Or is it only moving symbols around in darkness, without any inner world at all? This question sits at the heart of what philosophers sometimes call the hard problem of consciousness. Not the problem of how the brain processes information, but why processing information should create experience in the first place. Why should electrical activity inside a brain produce the feeling of hearing music, or falling in love, or staring quietly at the night sky while your thoughts drift somewhere beyond language? Some scientists believe consciousness emerges naturally once information becomes sufficiently interconnected and complex, almost the way a whirlpool emerges from flowing water. No single water molecule contains a whirlpool by itself, yet together, under the right conditions, a larger pattern appears. Others believe consciousness may be something deeper, perhaps even woven into reality itself in ways we do not yet understand. And tonight, we're going to slowly wander through these ideas together, not as a debate to win, not as a lecture to survive, but as a kind of quiet exploration. Because consciousness is not only a scientific mystery, it is also deeply personal. Every memory you have ever held, every fear, every dream, every hope for tomorrow, exists within this strange inner light we rarely stop to examine. In a way, consciousness is the closest thing you will ever encounter, and also the most difficult thing to explain. It is what allows the universe to hear music through human ears, to feel rain on human skin, to wonder about existence through human minds. And perhaps the strangest part of all is this. The universe spent billions of years as silent matter drifting through darkness. Stars burned, galaxies collided, planets formed and shattered long before anything alive ever opened its eyes to witness them. And then, somewhere on a small rocky planet orbiting an ordinary star, matter began waking up. Atoms became cells, cells became nervous systems became minds, and eventually the universe developed the ability to sit quietly in the dark, asking itself what consciousness is, which is exactly what you're doing now. And as this thought settles softly into the background of your mind, like distant rain against a window, another question slowly begins to emerge. If consciousness feels so immediate, so personal, so undeniable, why is it still so difficult to explain at all? There's a strange moment that sometimes happens late at night, especially when the world grows quiet enough for your thoughts to echo a little more clearly. You suddenly become aware that you're experiencing reality, not just moving through it automatically, but actually experiencing it from the inside. Maybe you notice the softness of a blanket against your arm, or the distant sound of traffic outside your window, or perhaps a memory drifts into your mind for no obvious reason at all. An old classroom, a childhood hallway, the smell of rain on warm pavement years ago. And somehow all of those sensations arrive wrapped in feeling. That part is important, because your brain is not simply detecting information, it is experiencing information. And surprisingly, modern science still does not fully understand how that happens. In fact, this mystery has become so famous among philosophers and neuroscientists that it has its own name, the hard problem of consciousness. The phrase was popularized by philosopher David Chalmers in the 1990s, though people had been struggling with the idea for centuries before that. The problem itself sounds deceptively simple. Why does physical activity inside the brain produce subjective experience at all? Or, to put it another way, why does it feel like something to be you? Your brain contains billions of neurons, tiny cells exchanging electrical and chemical signals in vast interconnected networks. Scientists can observe these signals using brain scans and electrical recordings. They can see regions becoming active when you recognize a face, remember a song, or feel pain. But even if we mapped every neuron perfectly, even if we understood every electrical pulse in complete detail, there would still remain a strange unanswered question. Why should any of that activity feel like anything from the inside? Imagine you place a kettle of water on a stove. Physics can explain the heating process beautifully. Molecules move faster, steam forms, pressure increases. Every step follows understandable physical rules. But consciousness is different. Suppose scientists describe every single process happening in your brain while you look at a sunset. They explain how light enters your eyes, how signals travel through the visual cortex, how memories and emotions become associated with colour and shape. Even after all of that, something still seems left over: the experience itself, the feeling of the sunset, the quiet beauty of orange light fading into evening clouds. That inner sensation is what philosophers often call qualia, the private texture of experience itself, the redness of red, the bitterness of coffee, the ache of grief, the warmth of nostalgia. And this is where things begin to feel surprisingly strange, because science is extremely good at describing systems from the outside. It measures behavior, structure, movement, interaction. But consciousness is known only from the inside. You do not observe your sadness the same way a scientist observes a storm cloud. You feel it directly, and no one else can access your experience completely. Right now, you probably assume other people are conscious too. Friends, strangers, people sitting quietly in apartments on the other side of the planet, listening to the same rainstorms and carrying the same invisible worries. But technically, you can never fully prove another person has subjective experience. You infer it, you trust it. You see behaviour that resembles your own inner life and naturally conclude there must be awareness there too. But you cannot climb inside another person's consciousness to verify it directly. In some sense, consciousness is the most undeniable thing you know, and also the most private. Philosophers sometimes illustrate this mystery using a strange thought experiment called the philosophical zombie. Despite the slightly dramatic name, it has nothing to do with shambling monsters wandering through abandoned shopping malls. Instead, imagine a person exactly like you in every visible way. This person laughs at jokes, drinks tea, talks about childhood memories, complains about being tired on Monday mornings. Maybe they even enjoy sleepy science videos late at night. From the outside, they appear completely normal, but internally, there is no experience at all, no inner world, no feeling, no awareness behind the eyes, just behaviour without consciousness. Now, whether such a being could actually exist is deeply debated, but the thought experiment reveals something important. Behaviour alone does not automatically explain experience. A machine might imitate consciousness perfectly while remaining entirely empty inside, or perhaps not. And suddenly, we arrive at another unsettling possibility. How would we ever know the difference? Modern artificial intelligence has made this question feel much less abstract than it once did. Computers can now generate language, recognize faces, compose music, and simulate conversation with remarkable fluency. They process information in ways that increasingly resemble aspects of human cognition. But does processing information create awareness? A calculator processes numbers. A thermostat responds to temperature. A navigation system predicts traffic patterns. At what point, if any, does processing become experience? No one knows. Some researchers believe consciousness naturally emerges when information becomes sufficiently integrated and self-reflective, like countless tiny threads woven together tightly enough that a new pattern suddenly appears. Others argue that no amount of computation alone can ever produce subjective feeling, that perhaps consciousness requires something fundamentally different from calculation. And this uncertainty has created one of the deepest divides in modern philosophy of mind. But before the mystery feels too abstract, it helps to remember something surprisingly ordinary. Most of your own brain activity already happens outside awareness. Right now, your body is regulating temperature, balancing hormones, controlling breathing, adjusting posture, filtering sounds, predicting sensory input, all without asking permission from your conscious mind. Conscious awareness appears to be only a tiny illuminated island floating above an enormous unconscious ocean. You're not consciously controlling your heartbeat. You're not consciously constructing every visual detail around you. You're not consciously calculating the meaning of every word you hear. The brain performs these tasks automatically and silently, like backstage workers changing scenery in darkness, while the spotlight remains fixed on the main performance. And perhaps that is part of why consciousness feels so mysterious. We experience only the finished performance, not the hidden machinery underneath. Some scientists compare conscious awareness to a theatre stage. Countless unconscious processes operate behind the curtains: memory, emotion, perception, language, prediction. But only a small portion enters the spotlight at any given moment. That spotlight becomes your conscious experience. The thought you are currently thinking, the sentence you are currently hearing, the faint emotion drifting quietly through your chest. And yet even this metaphor leaves the deepest question untouched. Why should there be a spotlight at all? Why should any physical process become illuminated by awareness? Why does the universe contain not only matter and energy, but experience? At the moment, no theory fully answers that question. Neuroscience continues making extraordinary progress mapping the brain. Psychology continues uncovering patterns of perception and cognition. Artificial intelligence continues blurring the line between simulation and understanding. And still, the hard problem remains waiting quietly underneath it all, like a distant light at the bottom of a deep ocean trench, not unreachable perhaps, but still far below where human understanding has managed to descend. And strangely enough, the deeper scientists investigate consciousness, the more they begin discovering that awareness may not be a fixed thing at all. It may shift, bend, fragment, disappear, and return again in ways far stranger than we usually imagine during ordinary waking life. Because consciousness, as it turns out, does not exist in only one form. It moves through many different states, like weather moving across the surface of the sea. For most of the universe's history, there was nobody here to notice it. No eyes watching the stars, no minds wondering about existence, no quiet thoughts drifting through the dark at 2 a.m, asking impossible questions about consciousness and reality. Just silence, or at least the kind of silence that exists before anything living has learned to listen. Nearly 14 billion years ago, the universe began in conditions so hot and dense that matter itself could barely exist in stable form. Space expanded, temperatures cooled, tiny particles formed, hydrogen and helium drifted through vast darkness like cosmic fog spreading endlessly in every direction. And for a very long time, nothing felt anything. Stars ignited one by one across the young universe, enormous furnaces burning quietly in the dark. Inside those stars, heavier elements slowly formed under crushing pressure. Carbon, oxygen, iron, calcium. The atoms that now exist inside your body were forged during those ancient stellar fires long before Earth existed at all. In a strangely literal sense, your consciousness is made from the ashes of dead stars. That thought alone feels almost dreamlike. The calcium in your bones, the iron in your blood, the oxygen flowing through your lungs tonight, all of it once drifted through exploding stars billions of years ago, and yet those ancient stars were not conscious. They burned magnificently, but blindly. Galaxies collided in silence. Black holes swallowed matter without experience. Entire worlds formed and vanished unnoticed for billions upon billions of years. Then eventually, on at least one small rocky planet orbiting an ordinary yellow star, something changed. Chemistry became biology, and biology began doing something the rest of the known universe had never done before. It started paying attention. At first, probably only in the faintest possible way. Simple organisms learned to react to light. Tiny cells sensed chemicals in surrounding water. Primitive life forms moved toward nutrients and away from danger. Not because they understood anything consciously the way humans do, but because evolution favors systems that successfully respond to their environment. And slowly, across unimaginable stretches of time, those systems became more sophisticated. Creatures developed nervous systems. Nervous systems developed memory. Memory allowed prediction. Prediction improved survival. Eventually, some organisms no longer reacted only to the present moment. They began carrying tiny internal models of reality inside themselves. A creature that remembers danger survives longer than one that forgets. A creature that predicts movement catches more food than one that merely reacts too late. And so evolution quietly rewarded awareness, little by little, over hundreds of millions of years. Consciousness may not have appeared suddenly like a light switch snapping on in darkness. It may have emerged gradually, like dawn, so slowly that no single moment could ever truly be called the beginning. Imagine an early fish swimming through ancient oceans hundreds of millions of years ago. Somewhere inside its primitive nervous system, electrical signals coordinate movement, perception, and survival. It detects motion, it avoids predators, it seeks food. Now imagine that system becoming slightly more complex over countless generations. The creature begins anticipating events before they happen. It remembers patterns. It distinguishes familiar from unfamiliar. And eventually, perhaps, there emerges the faintest flicker of something resembling experience. Not human thought, not language, not self-reflection. Just a dim inner world. A tiny fragment of awareness moving quietly through prehistoric seas. From there, evolution continued layering complexity upon complexity. Mammals developed richer emotional systems. Social animals learned cooperation, empathy, and communication. Brains expanded, memory deepened, perception sharpened. At some point, consciousness may have crossed another threshold entirely. The ability not only to experience the world, but to think about experience itself. A dog waiting near the door for its owner probably experiences something emotional. An octopus solving puzzles may possess a surprisingly rich inner life. Certain animals recognize themselves in mirrors, suggesting some form of self-awareness. And then eventually, humans appeared. A species capable of imagining the future, remembering the distant past, inventing mathematics, composing music, worrying about tomorrow's emails while standing in the shower, and perhaps most strangely of all, a species capable of wondering why consciousness exists in the first place. You could almost describe the history of life as the gradual deepening of awareness. Matter learned to react, then to remember, then to predict, then to feel, then to reflect upon itself. And tonight, somewhere within that ancient evolutionary chain, your own consciousness now sits quietly listening to these words, carrying inside it the accumulated history of billions of years of cosmic and biological change. That is an astonishing thing to pause and consider, because when you look up at the stars, the universe is not observing itself through magic, it is observing itself through biology, through nervous systems sculpted slowly by evolution, through brains built from ancient matter, through conscious creatures sitting awake in the dark wondering what awareness actually is. Some scientists believe consciousness is simply what sufficiently complex information processing feels like from the inside. In this view, awareness emerges naturally once a system becomes intricate enough, much like whirlpools emerge from flowing water, or hurricanes emerge from atmospheric motion. No individual water molecule contains the hurricane by itself, but under the right conditions, a larger pattern forms. Perhaps consciousness works the same way. Neurons alone may not be conscious, but billions of neurons exchanging signals across dense interconnected networks may generate something entirely new, an inner world, a sense of self, a flowing stream of experience. Others argue the mystery goes deeper than emergence alone can explain. They point out that even if we perfectly describe how information flows through the brain, we still have not explained why those processes should produce subjective feeling. Why should evolution create not only intelligent behavior, but actual experience? Why should pain hurt instead of merely triggering reactions? Why should beauty feel beautiful? Why should loneliness ache? Natural selection can explain why organisms behave adaptively, but whether it fully explains why awareness exists at all remains deeply uncertain, and perhaps that uncertainty is part of what makes consciousness feel so hauntingly unique, because unlike stars or oceans or gravity, consciousness contains an interior. There is something it feels like to exist as you. Right now, somewhere inside your brain, countless neurons are firing silently. Signals move through microscopic gaps, memories flicker, emotions rise and fall like tides, and from all of that unconscious activity emerges a single unified experience. This moment, the sound of this voice, the feeling of your breathing, the quiet awareness resting gently behind your thoughts. Matter, after billions of years of drifting through darkness, somehow learned to experience itself. And the deeper scientists study that transformation, the stranger the brain itself begins to appear. Because consciousness may not live in one place at all. It may emerge from an intricate conversation happening across the entire brain, like music arising from an orchestra, rather than any single instrument alone. Long before there were human thoughts, before language, before memory became stories whispered between generations, life on Earth was already solving problems, tiny ones at first. Simple organisms drifting through ancient oceans had no philosophy, no sense of identity, no dreams about the future. And yet even the earliest forms of life faced a basic challenge that still shapes every living creature today. How do you survive long enough to remain alive? That question may seem obvious now, but it quietly transformed the history of the universe. Because once life began trying to survive, it also began gathering information. The earliest organisms probably did not experience the world in any rich conscious sense. A bacterium moving toward nutrients in warm water was not contemplating existence beneath the stars, but it was responding to its environment in organized ways. It sensed differences, light versus darkness, warmth versus cold, safety versus danger. And in a very distant evolutionary sense, that may have been the beginning of awareness, not consciousness as you know it tonight, but the first faint outline of something that would eventually become consciousness. Imagine an ancient ocean billions of years ago. Microscopic organisms drift through mineral-rich water beneath volcanic skies. Some move randomly, others gradually evolve the ability to detect chemical gradients in the water around them. If nutrients are stronger in one direction, they move toward them. If toxins increase, they move away. This tiny improvement matters enormously. The organisms better at sensing their environment survive more often. They reproduce more successfully. Over immense spans of time, evolution rewards systems that gather information efficiently. Life begins paying attention. At first, only chemically, then electrically, then behaviourally, and eventually, perhaps experientially. One of the strangest things about evolution is that it does not plan ahead. There was never a moment when nature decided to invent consciousness. No grand blueprint existed saying, "One day there shall be poetry and insomnia and people staring thoughtfully out rainy windows." Instead, evolution works through countless tiny advantages accumulating gradually across millions of years. A creature that predicts danger slightly earlier survives more often. A creature that remembers food locations wastes less energy. A creature that recognizes social signals avoids conflict or finds mates more successfully. Awareness, memory, and prediction slowly become biologically valuable. And over time, nervous systems grow increasingly sophisticated. At some point, simple reflexes are no longer enough. Imagine touching something hot. Your hand jerks away almost instantly. Part of that reaction happens before conscious thought even arrives. But consciousness adds something extra beyond reflex. It allows learning, anticipation, simulation. You remember the pain later and avoid repeating the mistake. Now imagine early animals evolving the ability to form internal maps of their surroundings. Suddenly the world is no longer just immediate reactions. It becomes something represented internally. A creature can begin predicting what may happen next. And prediction changes everything. Some neuroscientists believe the brain is fundamentally a prediction machine. Even now, your own brain constantly anticipates reality before it fully arrives. It predicts sounds, movement, language, and sensory input continuously. In many ways, perception itself may be partly controlled prediction. That sounds strange at first, but you experience it constantly. Have you ever thought your phone vibrated, only to realize it never actually did? Or heard your name briefly in a crowded room where nobody called you? Your brain often guesses reality before confirming it completely. Usually those guesses are helpful. Occasionally they become little errors, tiny glimpses into how much of perception is actively constructed inside the mind. And this predictive ability may have deep evolutionary roots. A nervous system that merely reacts to danger after it happens is slower than one that anticipates danger before it fully arrives. So evolution increasingly favoured brains capable of simulation. The world outside became mirrored by smaller internal worlds inside nervous systems, and gradually awareness may have deepened alongside those simulations. Creatures evolved eyes capable of detecting increasingly detailed visual information, ears sensitive to vibration, memory systems capable of storing experience, emotional systems that guided behaviour towards survival and away from harm. Fear became useful, pleasure became useful, curiosity became useful. Even pain, unpleasant as it is, became one of evolution's most effective teaching tools. A creature that forgets pain easily may repeat deadly mistakes. A creature that remembers suffering learns caution. And somewhere inside these expanding biological systems, something remarkable may have begun emerging. Not merely behaviour, experience. There is an important difference between a thermostat detecting temperature and an animal feeling discomfort from cold. One processes information mechanically, the other may possess an inner world attached to that information. Exactly when experience first appeared remains completely unknown. Perhaps consciousness emerged gradually enough that no clear boundary exists at all. Some scientists now think consciousness may operate more like a spectrum than a switch. Not fully absent in simple organisms and fully present only in humans, but existing in varying degrees across life. A dog waiting sadly beside a door likely experiences emotional states. An octopus solving puzzles may possess forms of awareness surprisingly unlike our own. Certain birds remember hundreds of hidden food locations months later. Dolphins recognize themselves in mirrors. Elephants appear to mourn their dead. The more researchers study animal cognition, the more difficult it becomes to draw a sharp line separating human consciousness from the rest of nature. Perhaps consciousness did not suddenly appear. Perhaps it deepened, layer by layer, generation after generation, like dawn slowly brightening a landscape before sunrise fully arrives. And eventually, evolution produced brains capable not only of sensing reality, but reflecting upon it. Humans developed language, abstract reasoning, imagination, and self-awareness. We began constructing stories about ourselves and the universe. We created religions, philosophies, science, mathematics, and art. But beneath all of that complexity may still lie the same ancient, biological impulse that shaped the earliest nervous systems long ago. The need to navigate reality successfully. The need to predict what happens next. The need to survive. And perhaps consciousness itself emerged because experience became evolutionarily useful. A creature capable of integrating memory, emotion, prediction, sensation, and social awareness into a unified inner model may simply navigate the world more effectively than one operating through isolated reflexes alone. In this sense, consciousness may not be separate from biology at all. It may be one of biology's most extraordinary inventions, a way for matter to create an internal simulation of reality, detailed enough to guide survival through an unpredictable world. And yet, even if evolution explains why consciousness became useful, another mystery still remains quietly waiting underneath. Why should any of these processes feel like anything from the inside at all? Why should prediction become experience? Why should electrical activity inside nervous tissue produce the sensation of fear, wonder, loneliness, or beauty? Evolution may explain how awareness became increasingly sophisticated, but the deeper question, why there is an inner world accompanying those processes, still lingers softly in the darkness. And the closer scientists look at the brain itself, the stranger that inner world begins to appear, because your experience of reality may not be a direct window onto the universe. It may be something your brain is actively constructing moment by moment, more like a controlled dream than we usually realize. Right now, your brain is performing an astonishing act of construction. It may not feel that way, of course. It feels as though you're simply perceiving reality directly. You hear sounds, you see shapes and colours, you feel the texture of fabric against your skin and the slow rhythm of your breathing. The world appears immediate and stable, almost as though your mind were a clear window, looking outward onto reality exactly as it is. But neuroscience increasingly suggests something stranger. Your experience of reality may be less like a camera recording the world, and more like a controlled hallucination carefully guided by sensory input. That phrase can sound dramatic at first, especially because the word hallucination usually brings to mind something frightening or disconnected from reality. But scientists do not mean that your mind is inventing everything randomly like an untethered dream. Instead, the idea is subtler. Your brain is constantly predicting reality before fully receiving it, and much of what you consciously experience may be the brain's best ongoing guess about what exists around you. Imagine walking through your home in the dark late at night. You already know where the furniture is. Your brain predicts the hallway layout before your eyes clearly confirm it. You move carefully around corners, expecting doors and walls to remain where they were yesterday. Most of the time, your predictions are correct. In fact, your brain depends on prediction constantly because the outside world changes too quickly for pure passive observation alone. Sensory information arrives incomplete, noisy, and delayed. Light must enter your eyes. Signals travel through nerves. The brain interprets patterns and compares them against memory. This process takes time. Tiny fractions of a second, perhaps. But enough that if your brain waited passively for every detail before constructing experience, reality would feel slow and disjointed. So instead, the brain anticipates. It fills gaps. It edits. It smooths reality together into one continuous experience. In a way, your conscious world is partially assembled in advance, and occasionally the brain's predictions become visible to you precisely because they make mistakes. Think about the strange moment when you believe your phone vibrated in your pocket, only to realize it never did. Or the way you sometimes hear your name briefly in a crowded room full of unrelated conversations. Your brain expects meaningful signals so strongly that it occasionally creates them prematurely. Optical illusions reveal something similar. A drawing on paper suddenly appears three-dimensional. Still images seem to move. Two identical colours appear completely different depending on surrounding shadows and context. These illusions do not expose weakness in the brain so much as they expose its strategy. The brain is not trying to build a perfectly objective copy of reality. It is trying to build the most useful model possible for survival. And usefulness is not always the same thing as absolute accuracy. In fact, some neuroscientists argue that evolution never optimized the human brain for truth itself. It optimized the brain for survival. A creature that reacts quickly to possible danger survives more often than one that analyzes every detail with perfect caution. Better to mistake a stick for a snake occasionally than mistake a snake for a stick too late. And so the brain became deeply predictive. It constantly asks, what am I most likely about to experience next? Then it quietly prepares reality ahead of time. This may also explain why dreams feel so convincing while they are happening. When you dream, your brain continues generating a world internally, even though external sensory input becomes dramatically reduced. You may walk through impossible cities, speak with people long gone from your life, or drift through landscapes that shift shape the moment you look away from them. And yet, while dreaming, those experiences often feel real. The emotional centers of the brain remain highly active during dreams, while regions associated with critical reasoning become quieter. Your internal simulation continues running, but the part questioning inconsistencies softens into the background. A hallway becomes an ocean. A childhood friend suddenly becomes your teacher. Time stretches strangely, and somehow your mind accepts it all effortlessly. Dreams reveal something profound about consciousness. The brain is capable of generating entire experienced realities from within itself. That realization becomes even stranger when you consider waking life. Because even now, your ordinary experience depends heavily on internal construction too. The colour red does not exist out there in the universe exactly the way you experience it. Outside your mind, there are only electromagnetic waves interacting with matter. Your brain transforms those physical signals into the felt experience of colour. The same is true for sound. air vibrations become music only when nervous systems interpret them as experience. In some sense, the world you consciously experience is partly created inside you, not invented from nothing, but translated, constructed, rendered into awareness by the brain. This predictive model of perception has become increasingly influential in neuroscience over recent decades. Some researchers describe the brain as a kind of prediction engine continuously attempting to minimize surprise. The brain builds internal expectations about reality and constantly updates those expectations using incoming sensory information. You could almost imagine consciousness as a conversation between expectation and reality. Too much prediction without sensory correction may drift toward hallucination. Too much raw sensory chaos without prediction would feel overwhelming and incoherent. Healthy perception may exist somewhere between those extremes, a controlled dream anchored gently to the outside world. And occasionally, scientists glimpse what happens when that balance shifts dramatically. Certain neurological conditions alter perception in extraordinary ways. People may hear voices, perceive movement where none exists, or experience distortions of time and identity. Psychedelic substances can temporarily loosen the brain's predictive filters, allowing unusual connections and sensory experiences to emerge. Under these altered states, familiar reality can suddenly appear fluid and unstable. Walls seem to breathe. Time stretches. The boundaries between self and world soften. Researchers studying these experiences often notice something fascinating. When the brain's usual predictive structure relaxes, consciousness becomes less rigidly organized. Regions that normally communicate very little suddenly exchange information freely, producing novel perceptions and emotional states. It is as though the brain's carefully edited version of reality becomes temporarily less constrained. And perhaps that is one reason consciousness feels simultaneously stable and fragile. Stable enough that you usually trust reality without question. Fragile enough that chemistry, injury, sleep deprivation, illness, or emotion can reshape experience surprisingly easily. Even memory itself is not perfectly reliable. Each time you remember something, your brain partially reconstructs the memory, rather than replaying it exactly like a video recording. Details shift subtly, emotions influence interpretation, fragments become stitched together into coherent stories. In other words, even your past exists partly as an active simulation, and yet despite all this fluidity, your experience usually feels seamless, stable, continuous. You wake each morning believing you are the same person who fell asleep the night before. The world appears coherent enough to navigate. Consciousness holds everything together with astonishing consistency most of the time. But beneath that smooth surface lies an incredibly complex act of construction, happening constantly inside the brain. A private universe assembled moment by moment from prediction, sensation, memory, and interpretation. Which raises another strange possibility. If your experience of reality is actively constructed inside the brain, then perhaps the self experiencing that reality is constructed too. And that question leads us toward one of the deepest mysteries of all. What exactly is the you inside your mind that feels so continuous, so familiar, and yet may itself be changing constantly beneath the surface? If you've ever pointed toward your head while saying me, you're in good company. Most people instinctively feel as though their consciousness lives somewhere behind the eyes, somewhere near the forehead perhaps. A quiet observer sitting inside the skull, looking outward through the windows of the senses. It feels natural to imagine a little you inside your brain, watching, thinking, deciding. But when neuroscientists peer into the brain itself, they do not find a tiny observer waiting in a control room. There is no miniature person pulling levers behind your eyes. No hidden theatre audience watching your thoughts unfold. Only biology. Soft tissue folded into elaborate patterns. Billions of neurons exchanging electrical signals across dense living networks. Tiny pulses flickering continuously through darkness inside the skull. And yet somehow, from all this physical activity, emerges awareness. The question is where, or perhaps more accurately, how? For a long time, scientists hoped consciousness might exist in one specific location inside the brain, a single command center where awareness happened. But the deeper neuroscience progressed, the more complicated the picture became. Consciousness does not appear to reside neatly in one isolated region. Instead, it seems to emerge from communication between many regions working together. Like music arising not from one instrument, but from an orchestra. To understand this more clearly, it helps to gently wander through the landscape of the brain itself. At the base of the brain lies one of the oldest structures evolution ever produced, the brainstem. The brainstem quietly regulates breathing, heartbeat, sleep cycles, and wakefulness. It works constantly in the background without asking for your attention. Right now, while you listen, your brainstem is helping keep you alive automatically. You do not consciously remember to breathe each second. The brain handles it for you. And interestingly, severe damage to parts of the brainstem can completely eliminate consciousness, even if much of the rest of the brain remains intact. This suggests something important. Consciousness is not only about thinking, it is also about wakefulness itself, the basic state of being present rather than absent. Nearby sits another structure called the cerebellum, tucked quietly at the back of the brain beneath the larger cerebral hemispheres. The cerebellum helps coordinate movement, balance, and precision. It contains an astonishing number of neurons, more than half the brain's total in fact, and yet, despite all that complexity, the cerebellum seems to contribute surprisingly little to conscious experience directly. People with major cerebellar damage often struggle physically, but their awareness remains largely intact. This tells scientists something very strange. Not all neural activity creates consciousness equally. A huge amount of processing can occur without entering awareness at all. Then we arrive at the cerebral cortex, the wrinkled outer layer people usually imagine when they picture the human brain. This vast folded structure is deeply involved in perception, memory, language, imagination, and conscious thought. Different regions specialize in different tasks. The occipital regions near the back process visual information. Temporal areas help process sound and memory. Parietal regions integrate sensory information and spatial awareness. Frontal regions contribute to planning, self-reflection, decision-making, and social behavior. But consciousness does not appear confined to any one of these regions individually. Instead, awareness seems to depend heavily on how these systems communicate with one another. One especially important structure involved in this communication is the thalamus. The thalamus sits deep near the center of the brain and acts almost like a relay hub, directing sensory information between different cortical regions. Some neuroscientists describe it as a kind of central switchboard, helping synchronize brain activity into unified experience. When communication between the cortex and thalamus becomes disrupted, consciousness often fades. This happens during deep anesthesia, certain seizures, coma states, and parts of deep sleep. The orchestra remains physically present, but the coordination begins to collapse, and without coordination, the music disappears. This idea has become increasingly important in modern theories of consciousness. Rather than searching for one consciousness spot, researchers now often focus on integration. How does the brain combine vision, sound, emotion, memory, bodily sensation, language, and thought into one seamless experience? because your consciousness does not feel fragmented. You do not experience colour separately from shape, or sound separately from emotion, or memory separately from identity. Everything arrives woven together into one unified moment, and that weaving process itself may be central to consciousness. Some scientists compare this to a theatre stage. Countless unconscious processes operate behind the scenes continuously. Your brain regulates balance, predicts language, filters irrelevant sounds, monitors body temperature, and performs thousands of hidden calculations every second. Most of this activity never enters awareness, but occasionally, certain information moves into a kind of global workspace, a shared mental stage where it becomes available to the rest of the brain. Suddenly you consciously notice the ticking clock, or the smell of rain, or a memory from years ago resurfacing unexpectedly. Awareness may function partly like attention, illuminating selected information from a much larger unconscious background. And remarkably, brain imaging studies support parts of this idea. When people consciously perceive something, scientists often observe widespread coordinated activity across multiple brain regions. When information remains unconscious, processing appears more localized and disconnected. Consciousness, in other words, may require large-scale cooperation, not isolated sparks, but synchronized patterns. This becomes even more fascinating when we consider something called the default mode network. The default mode network is a collection of interconnected brain regions that becomes especially active when your attention turns inward. During daydreaming, remembering the past, imagining the future, or reflecting on yourself, this network hums softly in the background. In many ways, it helps maintain your ongoing sense of personal identity, the quiet, inner narrator, the sense of me. And yet even this stable feeling of self may be more fragile than it appears. During deep meditation, psychedelic experiences, certain neurological conditions, or extreme states of focus, activity within this network can change dramatically. People often report losing the usual boundaries between self and world. Thoughts become quieter. Time feels altered. The normal sense of identity softens, as though the brain's internal story about you becomes temporarily less rigid. This raises an unsettling but beautiful possibility. Perhaps consciousness is not a single thing at all. Perhaps it is a constantly shifting process emerging from billions of interactions unfolding together moment by moment, a dynamic harmony rather than an object. And like all harmonies, it depends on timing, coordination, and delicate balance. Your awareness right now exists because countless neurons exchange signals in astonishing synchronization. Electrical rhythms pulse across networks continuously. Information flows between memory systems, sensory systems, emotional systems, and predictive systems faster than conscious thought can notice. The result feels effortless. But underneath that effortless feeling lies one of the most intricate processes known in the universe. A 3-pound organ made of ordinary matter somehow generating an inner world rich enough to contain music, dreams, fear, love, loneliness, imagination, and wonder. And perhaps the strangest part is this. Even though consciousness feels continuous, the self inside it may not be nearly as unified as it seems. Because when scientists examine certain unusual brain conditions, they begin discovering that the mind can divide, fragment, and reorganize itself in deeply unsettling ways. Almost as though the you inside your head is less permanent than you imagine. There is a curious thing your mind can do that very few systems in the known universe appear capable of. It can turn inward and observe itself. Right now, for example, you're not only hearing these words, you're also aware that you're hearing them. Somewhere inside your experience, there is a quiet layer of reflection, sitting gently behind perception itself. You can notice your thoughts, question your emotions, replay conversations from years ago while simultaneously judging whether you should still feel embarrassed about them. The mind does not merely experience reality, it also watches itself experiencing reality. And that strange looping ability may be one of the deepest clues we have about consciousness. Imagine sitting alone at night after a long day. Perhaps the room is dark except for a soft lamp glowing somewhere nearby. You replay something awkward you said earlier. Immediately another part of your mind comments on it. Why did I say that? Then another thought appears. You really need to stop replaying old conversations before sleep. And then perhaps another quieter awareness notices both thoughts happening at once. This layered structure inside the mind is astonishing. When you slow down enough to examine it carefully, your consciousness contains thoughts about thoughts, feelings about feelings, awareness observing awareness. Scientists and philosophers often call this metacognition, the mind's ability to think about its own thinking, and humans seem exceptionally skilled at it. You can imagine future versions of yourself. You can mentally travel backward into memory or forward into imagined possibilities. You can criticize your own beliefs, narrate your internal experiences, and construct elaborate stories about who you are as a person. In many ways, your sense of self may partly be a story continuously told by the brain. Not a false story exactly, but an actively maintained one. Because when neuroscientists examine the brain closely, they discover something surprising. There may not actually be a single unified self located anywhere inside the skull. Instead, the feeling of being a continuous person may emerge from many systems working together moment by moment. Memory systems, emotional systems, language systems, body mapping systems, prediction systems, social modeling systems, all woven together into one ongoing experience called you. Some researchers describe this using something called self-model theory. According to this idea, the brain builds an internal model not only of the outside world, but also of the organism experiencing that world. In simpler terms, your brain creates a simulation of you. That sounds strange at first, almost unsettling, but in practice, your brain already constructs models constantly. It models the position of your body in space. It predicts how other people may react emotionally. It estimates time, distance, danger, and intention continuously. So perhaps the self is another kind of model, a useful organizing structure helping consciousness navigate reality. And remarkably, there are moments when this model becomes visible precisely because it begins to break apart. Consider something called the rubber hand illusion. In this experiment, a person places their real hand out of sight while a fake rubber hand sits visibly in front of them. Both the hidden real hand and the fake hand are stroked gently at the same time. After a surprisingly short period, many people begin feeling as though the fake hand belongs to them. The brain incorporates it into the body model, and if the fake hand is suddenly threatened, people often react emotionally despite knowing intellectually that it is not truly theirs. This reveals something important. Your sense of bodily self is actively constructed. It is not simply given. Other neurological conditions reveal even stranger disruptions. Some patients lose the ability to recognize their own limbs as belonging to them. Others feel phantom limbs after amputations, vividly sensing arms or legs that no longer physically exist. The brain's internal body map persists even when reality changes, and perhaps most unsettling of all are split brain cases. In certain severe epilepsy treatments, surgeons once separated the connection between the brain's two hemispheres by cutting a structure called the corpus callosum. Afterward, researchers observed behaviours suggesting that the two hemispheres could operate with surprising independence. One hand might perform actions the other seemed unaware of. Information presented to one visual field could influence behaviour without entering verbal awareness. Some scientists began asking an extraordinary question: could two streams of consciousness exist inside one divided brain? The answer remains deeply debated, but the implication alone feels almost surreal. The unified self we experience so naturally may depend heavily on coordination between systems rather than a single indivisible observer. In other words, the you inside your mind may be less solid than it appears. And yet somehow, despite all this complexity and fragility, your consciousness usually feels continuous. You wake each morning believing you are the same person who fell asleep the night before. Memories stitched together into identity. Thoughts flow with enough stability that life feels coherent. But memory itself is surprisingly reconstructive. Every time you recall a moment from your past, the brain partially rebuilds it. Details shift subtly over time. Emotions influence interpretation. Some memories sharpen, while others blur around the edges. In a sense, your personal history is constantly being rewritten gently inside the mind. This raises a profound philosophical question. If your memories change completely, would you still be you? Centuries ago, philosopher John Locke suggested that continuity of memory plays a central role in personal identity. The self persists because memory links experiences together across time, but memory alone cannot fully explain consciousness either. There are patients with severe memory loss who still experience emotion, personality, and awareness in the present moment. Some cannot form lasting new memories, yet they continue laughing at jokes, enjoying music, feeling fear, or recognizing affection. Consciousness survives even when memory becomes fragmented, so perhaps the self is not one thing. Perhaps it is many overlapping processes held together temporarily by the brain's ongoing activity, a kind of dynamic pattern, like a whirlpool in water. The shape persists for a while even though the underlying molecules continuously change. In fact, nearly every atom in your body will eventually be replaced over time through ordinary biological processes. Cells die and regenerate. Proteins break down and reform. Neural connections strengthen and weaken constantly through experience. And yet through all this change, the feeling of I somehow continues, at least most of the time. Some contemplative traditions have explored this instability of self for thousands of years. Certain forms of meditation encourage people to observe thoughts and sensations without identifying with them completely. A thought appears, then disappears. An emotion rises, then fades. And beneath these shifting experiences, meditators sometimes report discovering that the self feels less like a fixed object and more like an ongoing flow of awareness. Modern neuroscience has become increasingly interested in these experiences because they may reveal something important. The self may not be the owner of consciousness. It may be something consciousness generates, a useful narrative, a stable center constructed from memory, prediction, sensation, and social identity. And perhaps that is why the mind spends so much time telling stories about itself, because stories create continuity. They hold the flowing river of experience together long enough for a person to feel like one enduring being moving through time. But consciousness itself may be far stranger and more fluid beneath the surface than the stories we tell about who we are, especially when consciousness enters states where ordinary identity begins dissolving almost entirely, like dreams, deep meditation, anesthesia, or the strange shifting landscapes between waking and sleep. At some point tonight, if you haven't already drifted there, your consciousness will begin changing shape, not disappearing all at once, not switching off like a machine losing power, but slowly, gradually, like a shoreline fading beneath evening fog. Your thoughts will loosen, time will soften, the steady structure of waking reality will begin dissolving into something stranger and far more fluid, and eventually, without fully noticing the transition, you may enter a dream. Dreams are among the most familiar experiences humans have, and also among the most mysterious. Almost everyone dreams, even if they rarely remember doing so. Entire worlds appear inside the sleeping mind. Conversations unfold, landscapes emerge, impossible events feel completely ordinary for a while. You may suddenly find yourself back inside your childhood home, only for the hallway to transform into an airport halfway through the dream. A friend becomes a stranger. A staircase leads underwater. Time behaves strangely. Logic bends softly around emotion, and somehow, during the dream itself, your mind usually accepts all of it without protest. This is remarkable when you pause to consider it, because dreams reveal something profound about consciousness. The brain can generate entire experienced realities internally. No sunlight actually enters your eyes during a dream landscape. No physical sound reaches your ears from dream conversations. No real movement occurs when you fly through impossible cities or wander across oceans made of stars. And yet the experiences often feel vividly real while they happen. Your heart may race during a nightmare. You may wake with genuine sadness after dreaming of someone long gone from your life. Sometimes dreams even solve creative problems or uncover emotions buried quietly beneath ordinary waking thought. In many ways, dreaming consciousness resembles waking consciousness more closely than we usually realize. Modern sleep science has uncovered extraordinary details about what happens inside the brain during sleep. Rather than shutting down completely each night, the brain cycles through different states in carefully orchestrated rhythms. As you fall asleep, brain activity begins slowing gently. The fast electrical patterns associated with active wakefulness gradually soften into slower synchronized waves. Muscles relax. Awareness narrows. External sensory information becomes less dominant. Then, roughly every 90 minutes or so, another state emerges. Rapid eye movement sleep, often shortened simply to REM sleep. During REM sleep, the brain becomes unexpectedly active again. Certain regions involved in emotion, memory, and imagery light up intensely. Meanwhile, areas associated with rational self-monitoring become quieter. The result is a peculiar form of consciousness, highly immersive, highly emotional, but often strangely unconcerned with logical consistency. It is almost as though the brain becomes a storyteller wandering freely without its usual editor. Dreams may combine memories, fears, desires, fragments of conversation, and random sensory traces into surreal narratives that somehow feel meaningful despite their instability. One moment you're speaking with someone from childhood. The next, you're walking through a city made entirely of water while searching for an exam you forgot to study for 15 years ago. And throughout it all, consciousness continues. This is important, because dreams demonstrate that awareness does not require accurate contact with external reality in order to exist. The brain alone can create a complete experienced world internally. Some neuroscientists have even suggested that waking perception itself may not differ from dreaming as radically as we assume. Both involve the brain constructing models of reality. The primary difference may be that waking consciousness is more tightly constrained by incoming sensory information. A dream is largely generated from within. Waking life is a controlled dream continuously corrected by external input. That idea sounds almost unsettling at first, but it aligns surprisingly well with modern predictive theories of the brain. Your mind constantly generates expectations, simulations, and interpretations even while awake. Reality is not passively recorded, it is actively assembled. Dreams simply reveal what the brain can do when those external constraints loosen dramatically. And occasionally consciousness becomes aware of the dream itself. This phenomenon is called lucid dreaming. During a lucid dream, the dreamer suddenly realizes they are dreaming while remaining inside the dream world. Some people then gain partial control over the dream environment. They choose to fly, explore imagined landscapes, speak intentionally with dream characters. For a brief period, consciousness becomes aware of its own simulation, while still immersed inside it. A dream observing itself. Lucid dreaming fascinates scientists because it blurs boundaries between waking awareness and dreaming consciousness. Brain scans show that certain self-reflective regions become more active during lucid dreams than during ordinary dreaming. The mind partially wakes up inside its own internally generated reality, and perhaps that image carries a strange metaphorical beauty too, consciousness realizing it exists inside a constructed world. But dreams are only one example of how fluid awareness can become. Even ordinary waking life contains many altered states. Think about moments when you become completely absorbed in something. Playing, music, drawing, gardening, running. Watching snowfall quietly through a window while time seems to disappear for a while. Psychologists often call this a flow state. In these moments, the usual inner narrator softens. Self-consciousness decreases. Awareness narrows into the present activity so completely that hours may pass almost unnoticed. The self becomes quieter. And then there are moments at the opposite extreme, times when consciousness feels fragmented or distant, exhaustion after long sleepless nights, fever dreams, anxiety spirals at 3 a.m. where thoughts loop endlessly through imagined futures that never arrive. Consciousness shifts continuously across many gradients. It is not fixed. And perhaps one of the strangest examples of all is anesthesia. Under general anesthesia, consciousness can vanish with startling completeness. One moment a patient counts backwards slowly, while bright hospital lights blur overhead. Then suddenly, nothing. No dreams, no passage of time, no inner experience at all. Hours later, consciousness returns as though a missing section of reality has simply been removed entirely. This deeply interests neuroscientists because the brain often remains active during anesthesia. Signals continue moving, basic biological processes continue functioning, and yet subjective experience disappears. What exactly vanished? What changed? Increasingly, researchers suspect consciousness depends not merely on activity itself, but on the coordination and integration of activity across large networks. Like an orchestra losing synchronization even while individual instruments continue playing separately. And this realization has transformed the scientific search for consciousness. Researchers no longer ask only, which brain region creates awareness? They also ask, what kind of organized activity allows experience to emerge at all? Because consciousness may not be a thing hidden somewhere inside the brain. It may be a process, a dynamic pattern, a constantly shifting state emerging from relationships between countless systems working together moment by moment. And if consciousness truly depends on patterns of integration, rather than isolated components alone, then perhaps understanding awareness requires asking not just how the brain processes information, but how information becomes unified into one seamless inner world in the first place. Your experience of reality feels unified. That may sound almost too obvious to mention at first, but when neuroscientists look closely at the brain, this simple fact becomes surprisingly difficult to explain. Right now, As you listen, your brain is processing many different kinds of information at the same time. Sound arrives through your ears. Your body senses temperature and pressure. Some part of your mind may still be replaying thoughts from earlier today. Another part may be imagining tomorrow morning. Somewhere in the background, your brain regulates breathing, heartbeat, posture, and balance continuously without conscious effort. And yet, despite all this parallel activity, your experience does not feel fragmented. You do not experience sound in one isolated corner of awareness while emotions float somewhere separately disconnected from memory. Instead, everything arrives woven together into one seamless moment, a single conscious scene. And scientists still do not fully understand how the brain accomplishes this. This mystery is sometimes called the binding problem. How does the brain bind together countless separate neural processes into one unified experience? Imagine attending a symphony orchestra. Violins, cellos, flutes, drums, and pianos all produce different sounds from different locations. Yet, when the music begins, your mind does not hear isolated instruments separately. You experience one coherent piece of music unfolding through time. Consciousness may work in a similar way. Different brain regions process different features of reality independently. Some neurons detect color, others respond to movement, others track sound, memory, language, emotional tone, or body position. And somehow, all of it becomes one unified awareness. When you see a red apple resting on a wooden table, separate neural systems process the redness, the round shape, the texture, the spatial location, the recognition that it is an apple, perhaps even a memory of its taste. But your consciousness does not present these as separate data streams. You simply experience an apple effortlessly, smoothly, as though reality arrives already assembled. One reason this mystery fascinates neuroscientists is because the brain itself is not organized like a single unified screen. It is more like a vast distributed network with specialized regions exchanging information continuously, and yet consciousness somehow transcends that fragmentation. Some researchers believe synchronized neural rhythms may help solve part of this puzzle. Different brain regions often oscillate together in coordinated electrical patterns, almost like musicians keeping time together during a performance. When synchronization breaks down, consciousness itself may become unstable. This is sometimes visible during seizures, deep anesthesia, certain neurological disorders, or altered states of awareness. The brain remains active, but coordination becomes disrupted. The orchestra continues playing, but the harmony begins to dissolve. Other theories suggest consciousness emerges when information becomes globally available across many systems simultaneously. In this view, awareness occurs when separate pieces of information become integrated into a shared mental workspace. A thought enters awareness not because one neuron fires, but because many systems suddenly gain access to the same information together. And perhaps this helps explain why attention feels so important to conscious experience. Think about how easily awareness shifts. A ticking clock may disappear completely from your awareness for several minutes, until suddenly you notice it again. The sound existed the entire time. Your ears continued receiving it. Your brain processed it unconsciously. But only when attention illuminated it did the ticking become part of conscious experience. Consciousness seems deeply connected not merely to information itself, but to what the brain selects, integrates, and prioritizes into awareness. And still, even these explanations leave something unresolved. Because integration alone does not fully explain subjective experience either. A computer network can integrate information. The internet integrates enormous quantities of information continuously. But does the internet feel like anything from the inside? Most scientists would probably say no, which means the mystery still remains. Why should unified information become experience at all? And perhaps nowhere does this mystery become more emotionally haunting than in certain extraordinary neurological cases. One of the most famous involves a musician named Clive Wearing. In the 1980s, a severe brain infection damaged parts of Clive Wearing's memory system so profoundly that he could no longer form stable long-term memories. His awareness seemed trapped inside an almost perpetual present moment. Every few seconds or minutes, he believed he'd just become conscious for the very first time. He repeatedly wrote desperate notes and journals saying things like, "I am finally awake now." Then moments later, "No, now I am truly awake." Again and again. And yet despite this devastating memory loss, much of his personality remained. He still loved music. He still recognized his wife emotionally. He could still play piano beautifully because certain procedural memories survived even while autobiographical continuity shattered. Cases like this reveal something deeply strange. Consciousness can persist even when memory becomes fragmented. The self may weaken, yet awareness remains. This raises difficult questions. How much memory is required to remain you? How much continuity does consciousness actually need? Perhaps the self is less stable than we normally imagine. Perhaps consciousness is constantly reconstructing identity moment by moment, stitching together sensation, memory, and prediction into the feeling of continuity. Like a film projector creating smooth motion from separate frames, the illusion feels seamless because the stitching happens so quickly. And maybe this is why the present moment itself feels strangely elusive. Some psychologists and philosophers describe consciousness as existing within what William James once called the specious present. Not a perfectly frozen mathematical instant, but a brief flowing window containing traces of past, present, and anticipated future together. Your experience of now is slightly stretched across time. The brain integrates recent moments into continuity so smoothly that awareness feels fluid rather than fragmented. Without this integration, consciousness might feel shattered into disconnected flashes. Instead, the mind quietly stitches experience together into an ongoing stream. And perhaps that stream is what we truly mean when we talk about consciousness. Not a fixed object hidden somewhere in the brain, but a process of continuous binding, a living integration of sensation, memory, emotion, attention, prediction, and self-modeling unfolding dynamically across time. And remarkably, even this unified stream of awareness may not remain entirely stable under all conditions, because certain experiences, meditation, psychedelics, sensory deprivation, trauma, deep flow states, or profound emotional absorption can temporarily loosen the boundaries holding consciousness together. The ordinary sense of self begins softening. Time stretches strangely. The distinction between observer and experience grows thinner, and as scientists explore these altered states more deeply, some begin wondering whether consciousness itself may extend beyond the ordinary waking structure we take for granted every day, which lead us gently toward one of the strangest possibilities of all. What if consciousness is not merely something the brain produces, but something reality itself may somehow participate in? Most of the time, your consciousness feels centered around a very stable idea. I'm listening, I'm thinking, I'm remembering. The feeling seems so natural that we rarely stop to examine it closely. The self appears continuous and solid, like the quiet center around which all experience revolves. And yet there are moments when that center begins to soften, moments when the usual boundaries of identity loosen slightly, and consciousness starts feeling less like a person gripping reality tightly, and more like awareness simply flowing through experience itself. You may have already encountered these moments many times without realizing how strange they truly are. Perhaps while listening to music late at night, perhaps while swimming alone beneath summer sunlight, perhaps while drawing, writing, running, gardening, or watching snow fall quietly outside a window while time seemed to thin and drift away. For a little while, the constant inner narrator grows quieter. The ordinary sense of me relaxes, and experience becomes strangely spacious. Psychologists often call one version of this state flow. A flow state occurs when attention becomes so deeply absorbed in an activity that self-conscious thought begins fading into the background. Athletes describe it during competition. Musicians experience it while performing. Artists sometimes lose entire afternoons inside concentrated creative immersion. Hours pass almost unnoticed. Actions feel effortless. Awareness narrows gently into the present moment. Interestingly, during flow states, activity in parts of the brain associated with self-reflection often decreases. The usual mental commentary softens. Consciousness becomes less occupied with monitoring itself constantly. And perhaps that is one reason flow feels so peaceful. For a brief period, the mind stops carrying the heavy weight of continual self-reference. No endless replaying of conversations, no anxious projection into tomorrow, no carefully maintained personal narrative, just direct participation in experience. Meditation may reveal something similar, though often even more deeply. Across thousands of years and many different cultures, contemplative traditions have explored consciousness through sustained attention and stillness. Despite enormous differences in philosophy and practice, many meditators describe surprisingly similar experiences when the mind becomes very quiet. Thoughts continue appearing, but feel less solid. Emotions rise and pass more freely. The boundary between observer and experience becomes less rigid, and sometimes the ordinary sense of self begins dissolving almost entirely. This can sound mystical at first, but neuroscience has become increasingly interested in studying these states scientifically. Brain imaging studies suggest that during certain forms of meditation, activity decreases in networks associated with autobiographical thinking and self-referential processing. In simpler terms, the brain regions involved in continuously constructing the story of me become less dominant for a while. The inner narrator quiets, and beneath that narrator, many people report discovering something unexpected. Awareness remains. Even when the usual feeling of identity softens, this creates a fascinating possibility. Perhaps consciousness itself is not identical to the self-story the brain normally maintains. Perhaps the self is something consciousness generates, not the other way around. Imagine sitting quietly beside a lake at dusk. At first, your thoughts race constantly. Plans, memories, worries, fragments of conversation, random songs looping through the mind. Then gradually, the mental surface begins calming. Not perfectly silent, perhaps, but less turbulent. And for brief moments, experience feels simpler. Just sound, breath, cool air, awareness itself. Many meditators describe these moments not as losing consciousness, but as losing the feeling of being trapped inside constant self-reference. And interestingly, altered time perception often accompanies these states as well. During deep meditation or intense flow, time may feel strangely expanded or compressed. Minutes pass like seconds, or brief experiences seem unexpectedly vast and spacious. This reveals something important about consciousness. Your sense of time is not fixed. It is actively constructed by the brain. Under ordinary waking conditions, the mind continuously stitches together memory, anticipation, sensation, and attention into the feeling of flowing time. But when attention changes dramatically, time itself changes too. You've probably experienced this countless times. A boring meeting stretches endlessly. A joyful evening disappears almost instantly. Anxiety slows moments painfully. Dreams compress entire narratives into minutes. Consciousness does not merely exist inside time. In many ways, consciousness helps create the human experience of time. And perhaps nowhere does this become more obvious than during moments when the self temporarily weakens. Certain contemplative traditions even suggest that the ordinary sense of self is partly an illusion maintained through constant mental activity. Not an illusion, meaning completely false, but an actively constructed process rather than a permanent entity. Modern neuroscience increasingly finds parts of this idea surprisingly plausible. The brain continuously integrates memory, body sensation, emotion, social identity, and prediction into the ongoing feeling of being a stable person moving through time. But under altered conditions, this construction can loosen, sometimes gently, sometimes dramatically. People undergoing profound meditative experiences occasionally describe awareness becoming boundaryless, as though the distinction between self and world grows thinner. Others report overwhelming feelings of interconnectedness or deep calm. Importantly, scientists remain cautious about interpreting these experiences metaphysically. Feeling connected to the universe does not automatically prove any cosmic theory about consciousness, but the experiences themselves are real, and they reveal how flexible conscious experience can become. Even ordinary waking identity may be far less fixed than it appears. This flexibility becomes even more striking when researchers study extreme altered states induced through sensory deprivation, trauma, psychedelics, or neurological disruption. Under such conditions, the normal structure of consciousness can transform dramatically. Space feels distorted, time bends strangely, identity fragments or expands, reality itself may seem dreamlike, and yet throughout these changes one thing often remains surprisingly persistent: awareness. The contents of consciousness shift continuously, but consciousness itself somehow continues witnessing those changes. This has led some philosophers and contemplative thinkers to wonder whether awareness might be more fundamental than the constantly changing mental stories attached to it, like an open space in which thoughts, memories, emotions, and identities briefly appear before dissolving again. Of course, neuroscience does not yet fully understand these experiences. Scientists continue debating what exactly meditation changes inside the brain and why altered states feel so subjectively powerful. But one thing has become increasingly clear: consciousness is not a rigid, fixed condition. It stretches, contracts, fragments, flows. Dreams become worlds. Flow states dissolve time. Meditation softens identity. And somewhere beneath all these shifting experiences remains the astonishing fact that matter arranged itself into a form capable of inner awareness at all, which makes the next mystery even stranger. Because there exists another state where consciousness does not merely soften or transform, it disappears entirely, or at least seems to, and when it returns, time itself may have vanished without leaving even the faintest trace behind. There is a moment before anesthesia takes effect that many people remember with unusual clarity: bright hospital lights overhead, soft footsteps somewhere nearby, a calm voice asking you to count backwards slowly. 10, 9, 8, and then nothing. Not darkness exactly, not sleep in the ordinary sense, not even the feeling of time passing, simply an absence. Hours later, consciousness returns abruptly. Perhaps someone is adjusting blankets nearby. Machines hum softly in the background. Your throat feels dry. A nurse asks how you are feeling, and somehow an entire section of existence appears completely missing. No dreams, no memories, no inner experience at all. This fascinates neuroscientists because anesthesia may be one of the clearest real-world examples of consciousness disappearing, while much of the brain and body continue functioning. Your heart still beats under anesthesia. Your lungs continue breathing with assistance. Neurons continue firing. Electrical activity continues moving through the brain. And yet the conscious world vanishes. What exactly disappeared? That question sits quietly at the center of one of neuroscience's deepest mysteries. At first glance, anesthesia might seem simple. Perhaps consciousness merely switches off when the brain slows down enough. But the reality appears far more complicated. Under certain anesthetics, the brain does not simply become inactive. In some cases, many regions remain surprisingly busy. Signals still travel. Sensory systems still receive information to some extent. Metabolic activity continues. The orchestra is still physically present. But something about the coordination changes. Modern researchers increasingly suspect that consciousness depends less on raw activity alone, and more on organized communication across large-scale brain networks. Awareness may require different parts of the brain to exchange information fluidly and integrate experience into one unified whole. Anesthesia appears to interrupt that integration. Imagine a vast city at night viewed from above. Millions of lights glow across streets and buildings. Cars move, signals travel, communication flows constantly through invisible networks. Now imagine the city's connections gradually failing. Neighborhoods become isolated. Messages stop arriving. Synchronization disappears. Individual lights still shine, but the city no longer functions as one coordinated system. Some neuroscientists believe something similar may happen during unconsciousness. The brain remains active locally, but loses the large-scale integration necessary for unified conscious experience. This idea becomes especially interesting when researchers examine communication between the cortex and deeper brain structures involved in arousal and coordination. During anesthesia, these long-range communication patterns often weaken dramatically. It is almost as though the brain's internal conversation fragments, and when the conversation fragments deeply enough, experience itself dissolves. One especially haunting aspect of anesthesia is the disappearance of time. When you sleep naturally, time still leaves traces. Dreams unfold. Fragments of memory remain. Even deep sleep often contains some faint sense that time passed. But under general anesthesia, people frequently describe something stranger. It feels instantaneous. One moment exists, then another moment exists later. Nothing lies between them, as though a section of reality itself had been removed. This has led some philosophers to wonder whether consciousness may be intimately tied to the experience of temporal continuity. Perhaps awareness depends partly on the brain continuously stitching moments together into an unbroken stream. When that stitching process collapses entirely, subjective time vanishes with it. And perhaps that is why anesthesia feels more unsettling to many people than ordinary sleep. Sleep still feels alive somehow. Anesthesia often feels like interruption. A blank page, inserted silently into experience. Of course, scientists continue debating exactly how different anesthetic drugs achieve these effects. Various substances influence the brain in different ways. Some strengthen inhibitory signaling, calming neural activity. Others interfere with communication between networks involved in attention, memory and awareness. But despite decades of research, no single explanation fully captures why subjective experience disappears. This uncertainty becomes even stranger when we compare anesthesia with other altered states. Dreaming consciousness remains vivid despite reduced sensory input. Meditation may quiet the self while preserving awareness. Certain neurological conditions disrupt memory without fully eliminating consciousness, and yet anesthesia can erase conscious experience with startling completeness. It is almost as though consciousness depends on a very delicate balance, one that can collapse surprisingly easily. Some researchers describe this balance using metaphors of harmony and coordination. A conscious brain may function less like a machine performing isolated calculations, and more like an orchestra maintaining precise synchronization across many interacting systems. When synchronization weakens too much, awareness fades, not because the individual instruments disappear, but because the music itself can no longer emerge. This idea aligns with a growing shift in consciousness research. Scientists increasingly suspect that consciousness is not stored somewhere inside the brain, like a hidden object waiting to be discovered. Instead, it may arise from patterns of dynamic integration unfolding across time. Consciousness as process, consciousness as coordination, consciousness as organized flow. And perhaps this explains why awareness feels both resilient and fragile at the same time. Resilient because the brain constantly repairs, adapts, and reorganizes itself. Fragile because tiny chemical changes can radically alter experience. A few molecules crossing neural pathways can transform terror into calm, erase pain, distort perception, or remove consciousness altogether. That realization carries a strange emotional weight. Your entire experienced world, every color, memory, hope, fear, and dream, depends on extraordinarily delicate biological processes unfolding continuously inside the skull, and yet most of the time, those processes operate so smoothly that reality feels perfectly solid, stable, continuous, reliable. Only in unusual states like anesthesia do we glimpse how thin the thread of ordinary awareness may actually be, how easily the inner world can disappear. And perhaps that fragility is part of what makes consciousness feel so mysterious in the first place. Because the more scientists study awareness, the stranger reality itself begins to appear. At the larger scales, the universe follows elegant physical laws with astonishing precision. But deep beneath ordinary reality, at the level of atoms and particles, physics itself begins behaving in ways so strange that even the scientists who discovered them struggled to accept what they were seeing. Particles behaving like waves. Possibilities existing before outcomes. Reality refusing to settle into definite form until interaction occurs. And for some thinkers, these strange discoveries raised an unsettling question. Could consciousness somehow be connected to the deeper structure of reality itself? Not proven, not established, but perhaps worth wondering about, carefully and slowly, like someone tracing faint shapes through fog in the dark. For most of human history, reality appeared solid and dependable. A stone was a stone. A tree was a tree. The moon remained in the sky whether anyone looked at it or not. Classical physics, the physics developed by Isaac Newton and later expanded through centuries of scientific discovery, described a universe that behaved almost like a vast cosmic machine. Objects moved according to precise laws. Causes produced predictable effects. If you knew the position and motion of every particle, at least in principle, you could predict the future like an unimaginably complicated clock. It was a comforting vision in some ways, stable, ordered, continuous. Reality existed independently out there, calmly unfolding whether human beings observed it or not. Then, in the early 20th century, physicists began looking more carefully into the microscopic world of atoms and subatomic particles. And reality started behaving strangely. very strangely. At first, the discovery sounded almost impossible. Tiny particles sometimes behaved like solid objects, and sometimes like waves spreading through space. Light acted both like a stream of particles and like rippling vibration. Matter seemed capable of existing in multiple possible states before measurement occurred. The deeper scientists investigated, the less ordinary reality seemed to resemble the intuitive world humans experience every day. Imagine tossing a pebble into a pond. The pebble lands in one clear location. Ripples spread outward afterward. Cause and effect remains straightforward. But in quantum experiments, particles sometimes behaved less like pebbles and more like possibilities, as though reality itself remained strangely unsettled until interaction occurred. One famous experiment illustrates this beautifully. Imagine shining tiny particles of light toward a barrier containing two narrow openings. Behind the barrier sits a screen recording where the particles arrive. If particles behaved like ordinary little objects, you would expect them to pass through one opening or the other, creating two simple bands on the screen behind. But something astonishing happens instead. Over time, the particles create an interference pattern, the kind of pattern normally produced by overlapping waves in water. It is almost as though each particle somehow passes through both openings simultaneously, interfering with itself like a wave spread across multiple possibilities. And yet when scientists attempt to measure which opening the particle actually travelled through, the interference pattern disappears. The particle suddenly behaves like a localised object again. This disturbed physicists profoundly, because the act of measurement itself appeared to change the outcome. Now, it is important to move carefully here. Popular culture often exaggerates these experiments dramatically, leading people to believe human thoughts magically create reality. The actual science is subtler and far more uncertain than that. But even in its careful scientific form, quantum mechanics introduce something deeply unsettling. At the smallest scales, reality does not always behave like a collection of solid, definite objects existing independently in familiar ways. Instead, quantum systems are often described using probabilities and possibilities until interaction forces a specific outcome to emerge. Some physicists describe this mathematically as a collapse from many possible states into one observed result. But the equations themselves do not fully explain what physically causes that transition, and that gap became known as the measurement problem. What exactly counts as a measurement? When do possibilities become realities? Why does nature appear indefinite in some situations and definite in others? Even the scientists who developed quantum mechanics struggled emotionally with these questions. Albert Einstein famously disliked the uncertainty embedded within quantum theory. He resisted the idea that probability might lie at the deepest level of reality, once remarking that he could not believe nature fundamentally plays dice with the universe. Others accepted the strange mathematics while remaining uncomfortable with its implications. Niels Bohr argued that quantum mechanics might simply reflect the limits of how humans can describe reality itself. Werner Heisenberg suggested that, at quantum scales, ordinary concepts like definite position and motion may no longer apply simultaneously in the familiar ways we expect. Reality, it seemed, was becoming slippery, difficult to picture clearly. And perhaps the strangest part of all was this: the quantum world remained mostly hidden from ordinary human experience. You do not notice quantum uncertainty while making breakfast or walking through a grocery store or listening to rain against your bedroom window. Everyday objects appear stable because enormous numbers of particles interact together continuously, smoothing microscopic uncertainty into the solid world we recognize. The strange behavior becomes most visible only under highly controlled conditions at extremely small scales. Still, the philosophical shock remained immense, because quantum mechanics suggested that reality at its deepest level may not resemble the solid deterministic universe humans once imagined. Instead, nature appeared filled with probabilities, relationships, and interactions more subtle than classical intuition allowed. Some physicists compared the quantum world to fog slowly settling into visible form. Before interaction, possibilities spread softly like mist across many potential outcomes. Then, measurement occurs, and one definite reality emerges. Others described quantum systems like musical harmonies, containing many overlapping notes simultaneously until the final chord resolves. Of course, these are only metaphors. The actual mathematics of quantum theory is extraordinarily precise and successful scientifically. Quantum mechanics predicts experimental results with astonishing accuracy. Modern electronics, lasers, medical imaging, and countless technologies depend on it working correctly. And yet, emotionally, the theory still feels deeply strange, perhaps because it challenges one of humanity's oldest assumptions, that reality exists fully formed and definite independent of observation. At the quantum level, nature seems less rigid than that, more fluid, more relational, more dependent on interaction itself. This does not necessarily mean consciousness creates reality. Many physicists reject that interpretation entirely. In modern science, observation often simply means physical interaction with a measuring system, not necessarily awareness inside a human mind. And yet the mystery remains compelling because quantum mechanics leaves certain philosophical questions strangely open. Why should measurement matter so much? What separates possibility from actuality? Why does reality appear probabilistic before interaction and definite afterward? Different interpretations of quantum mechanics attempt to answer these questions in radically different ways. Some suggest all possibilities continue existing simultaneously across branching realities. Others propose hidden underlying mechanisms not yet fully understood. Still others argue the equations merely describe information and prediction rather than objective reality itself. No single interpretation has achieved universal agreement, which means that more than a century after quantum mechanics transformed science, physicists still debate what the theory ultimately says about reality. That uncertainty has inspired both careful scientific exploration and enormous speculation. And somewhere within those speculations lies one particularly controversial possibility. If observation plays a role in how quantum systems become definite, then could consciousness itself somehow matter? Most physicists remain skeptical of that conclusion, but a few thinkers began wondering whether awareness and quantum measurement might be connected in ways not yet fully understood, not because the evidence proved it, but because the mystery itself remained unresolved. And as these questions slowly unfolded through the 20th century, reality itself began feeling increasingly difficult to separate from the act of observing it, almost as though the universe, at its deepest level, refused to become fully independent from the relationships unfolding within it, like shapes emerging slowly from fog only when light passes through them, or dreams settling briefly into clarity just before waking dissolves them again. Imagine two scientists sitting in separate rooms late at night. Between them rests a sealed box. Inside the box is an experiment involving a tiny quantum event, something microscopic and uncertain, like the possible decay of a radioactive particle. If the particle decays, a machine triggers. If it does not decay, nothing happens. Simple enough at first, but according to quantum mechanics, before measurement occurs, the system may exist in a strange state, containing multiple possibilities at once. Not fully one outcome or the other in the ordinary classical sense. but something more ambiguous and difficult to picture clearly. Now imagine one scientist opens the box and observes the result. For that scientist, the uncertainty appears resolved immediately. A definite outcome exists. But for the second scientist outside the room, who has not yet learned the result, the situation becomes strangely complicated. Has reality already settled into one outcome, or does uncertainty still remain from the outside observer's perspective? Questions like these deeply unsettled physicists during the 20th century because they suggested something profoundly uncomfortable. Reality itself might not behave as a single, perfectly objective story, unfolding identically for every observer at every moment. Instead, observation and information seemed woven into the structure of physical description far more deeply than classical intuition expected. One of the thinkers who explored these questions was physicist John von Neumann. He examined the strange chain created by measurement itself. Imagine measuring a quantum particle using a detector. The detector interacts with the particle. Then a scientist observes the detector. Then another scientist observes the first scientist. Then perhaps another observer watches all of them. Where exactly does uncertainty end and definite reality begin? At what point does possibility settle into actuality? This became known loosely as the von Neumann chain, an idea suggesting that measurement may involve an endless series of interacting systems without an obvious stopping point. And somewhere within this strange chain, a few thinkers began wondering whether consciousness itself might somehow play a role. Among them was physicist Eugene Wigner, who proposed one of the most famous thought experiments in quantum theory. Today, it is often called Wigner's friend. Imagine your friend performs a quantum measurement inside a closed laboratory while you remain outside unaware of the result. From your friend's perspective, a definite outcome has occurred, but from your perspective outside the room, the entire laboratory may still need to be described as a quantum system containing unresolved possibilities. In a sense, two descriptions of reality now coexist, one from inside awareness, one from outside. This creates a deeply unsettling question. Could reality itself depend partly on the perspective of the observer, or more carefully, does quantum mechanics imply that different observers may legitimately describe the same situation differently until information becomes shared? Modern physicists interpret these questions in many different ways. Importantly, most scientists do not conclude that human consciousness magically creates reality through thought alone. That idea is often exaggerated far beyond what mainstream physics supports. Still, the philosophical tension remains fascinating because quantum mechanics does not provide one universally accepted explanation for how possibilities become definite experiences, and perhaps that uncertainty resonates so deeply because human consciousness itself already feels strangely private and observer-centered. Your experiences exist from your perspective inwardly. No one else can directly access your awareness. You assume other minds exist because other people behave like conscious beings, but you never experience their consciousness directly. You experience only your own. In this sense, all conscious life already unfolds through subjective viewpoints, and quantum mechanics introduced a strange scientific framework in which observation, information, and perspective suddenly became far more important than classical physics had ever suggested. Some interpretations attempt to avoid this discomfort entirely. The many worlds interpretation proposes that every possible outcome continues existing across branching realities rather than collapsing into one single result. In this view, uncertainty reflects our limited perspective rather than genuine indeterminacy. Other interpretations suggest hidden underlying mechanisms may eventually restore a more classical understanding of reality. Still, Others argue that quantum mechanics describes information and probabilities rather than objective physical states directly. The debates continue even now. And remarkably, after more than a century of extraordinary experimental success, physicists still disagree about what quantum mechanics ultimately means philosophically. That lingering uncertainty leaves space for imagination, though careful scientists remain cautious, because the moment discussions turn toward consciousness, speculation can expand very quickly beyond available evidence. It is one thing to acknowledge that quantum mechanics raises strange questions about observation. It is another thing entirely to claim consciousness controls physical reality directly. Those are not the same idea, and maintaining that distinction matters enormously. Still, even without sensational conclusions, the emotional impact of these ideas remains powerful. The universe begins feeling less like a rigid machine and more like something relational, interactive, context-dependent, not necessarily unreal, but perhaps less solidly detached from observation than humans once believed. Imagine standing alone in thick morning fog. Shapes exist around you, but only gradually emerge as light and perspective reveal them. The landscape is real, yet your experience of it depends intimately on position, interaction, and visibility. Quantum theory sometimes feels emotionally similar. Reality appears less like a fully painted scene waiting passively in the distance, and more like something becoming defined through relationships and interactions unfolding continuously. Again, this does not prove consciousness creates the universe, but it does suggest that observation and physical reality may be intertwined more subtly than classical intuition expected. And perhaps that subtlety explains why these ideas continue haunting both physicists and philosophers alike. Because consciousness itself already occupies a strange position inside reality. We are not outside observers examining the universe from beyond existence. We are part of the universe examining itself from within. Matter studying matter. Awareness wondering about awareness. And the deeper scientists explored these questions, the more some thinkers began asking whether consciousness might require physics deeper than ordinary biology alone could explain. Could awareness somehow involve quantum processes inside the brain itself? Could the mysterious fluidity of quantum systems connect, in some distant way, to the mystery of subjective experience? Most researchers remained skeptical, but the questions persisted quietly enough that a few scientists became willing to explore them seriously, however controversial the ideas might become, and those explorations would eventually lead toward one of the most debated theories in all of consciousness research. The possibility that the brain may contain tiny structures where delicate quantum events briefly survive long enough to influence conscious experience itself. For most neuroscientists, consciousness emerges from ordinary biological activity. Neurons exchange electrical signals, networks integrate information. Awareness arises from complex communication unfolding across the brain. That remains the mainstream scientific view today, and yet, for some researchers, something about consciousness still feels incomplete, not because neuroscience has failed. Modern brain science has uncovered extraordinary insights into memory, perception, sleep, emotion, and awareness. But even after decades of progress, the deepest mystery remains stubbornly unsolved. Why should physical processes produce objective experience at all? Why should matter feel like something from the inside? For a small group of scientists and philosophers, this lingering mystery suggested a provocative possibility. Perhaps consciousness depends on physical processes deeper than ordinary neural signaling alone. And eventually this speculation led toward one of the most controversial ideas in modern consciousness research: the possibility that quantum processes may play a role inside the brain itself. One of the most famous versions of this idea was developed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. Together they proposed a theory with a rather technical name, orchestrated objective reduction. The name sounds intimidating at first, but the central intuition can be approached more gently. Penrose believed human consciousness might involve forms of understanding that cannot be fully explained through ordinary computation alone. He argued that human insight sometimes appears different from step-by-step algorithmic calculation, though many scientists strongly disagree with this conclusion. Hameroff, meanwhile, focused on tiny structures inside neurons called microtubules. Microtubules act partly like microscopic scaffolding within cells, helping maintain structure and transport materials. They exist throughout the body, but Hameroff suggested they might also support delicate quantum processes inside brain cells. And this is where the theory becomes highly speculative, but undeniably fascinating. According to Altshaw, quantum states inside these microscopic structures might briefly remain coordinated long enough to contribute to conscious experience before collapsing into definite outcomes. In simpler imagery, the theory imagines consciousness not only as electrical activity passing between neurons, but also as involving extremely subtle quantum events unfolding deep within the brain's microscopic architecture. Now, it is very important to move carefully here. This theory remains controversial. Many neuroscientists argue the warm, wet environment of the brain is far too noisy for delicate quantum states to survive meaningfully long enough to influence consciousness. Quantum effects are notoriously fragile. Tiny disturbances from surrounding environments typically destroy coherent quantum behavior extremely quickly. And for many years, this criticism alone caused most scientists to dismiss quantum consciousness theories almost entirely. But then something unexpected happened. Researchers began discovering genuine quantum effects in certain biological systems. Not consciousness specifically, but biology itself appeared capable, in some cases, of using quantum behavior in surprising ways. For example, studies of photosynthesis suggest some plants and bacteria may exploit subtle quantum effects to transfer energy remarkably efficiently. Certain migratory birds may use quantum-sensitive chemical reactions to help navigate Earth's magnetic field during long-distance migration. Even smell itself may involve quantum-scale interactions according to some hypotheses. Suddenly, quantum biology no longer seemed completely impossible. Living systems, under some conditions, appeared capable of preserving delicate physical processes once assumed too fragile for biology to use at all. This did not prove quantum consciousness, not even close. But it softened one of the strongest objections slightly. Perhaps biology could interact with quantum phenomena more subtly than scientists previously expected. Still, enormous problems remain for theories like Altshaw. There is currently no widely accepted experimental evidence demonstrating that quantum processes inside microtubules generate consciousness. Many researchers believe ordinary neural computation remains more than sufficient to explain awareness without introducing quantum mechanics at all, and importantly, invoking quantum physics does not magically solve the hard problem either. Even if quantum events contribute to brain activity, we would still face the deeper question: why should any physical process, classical or quantum, produce subjective experience? Quantum mechanics may deepen the mystery rather than resolve it, and yet the idea continues attracting attention partly because consciousness itself already feels unusual compared to ordinary physical systems. Your awareness seems unified despite distributed brain activity. Your thoughts sometimes arrive suddenly rather than step-by-step mechanically. Creativity, intuition, imagination, and subjective feeling often feel fluid and difficult to reduce neatly into rigid computational rules. Of course, feelings alone do not prove anything scientifically, but they help explain why the question persists. And perhaps the emotional power of quantum consciousness theories comes less from their current scientific status, and more from what they reveal about the limits of our understanding. Consciousness still sits at the edge of explanation. Physics still contains unresolved interpretive mysteries, and whenever two great unknowns overlap, human imagination naturally begins searching for hidden connections. Some researchers remain firmly skeptical, others remain cautiously curious. Most agree the evidence remains incomplete, but nearly everyone agrees on one thing: we still do not fully understand how consciousness emerges from physical reality, and perhaps that uncertainty itself deserves a kind of quiet respect, because science progresses not only through answers, but through carefully framed questions. The history of science contains many moments where ideas once dismissed entirely later became accepted, and many others where beautiful theories eventually turned out to be wrong. Quantum consciousness may someday prove unnecessary, or incomplete, or perhaps partially insightful in ways nobody yet anticipates. At the moment, nobody truly knows. And that uncertainty creates a strangely beautiful intellectual landscape, a place where neuroscience, physics, philosophy, and subjective experience all meet near the edge of human understanding, like explorers standing together at the shore of a dark ocean at night, able to see only fragments illuminated briefly by moonlight. Still, regardless of whether quantum mechanics ultimately plays any direct role in consciousness, these theories point towards something important. The universe may be far stranger than ordinary intuition suggests. Reality at its deepest levels already behaves in ways that challenge classical assumptions about certainty, separateness, and objectivity. Consciousness, meanwhile, remains the only phenomenon we know directly from the inside, and when those two mysteries touch each other, the mystery of quantum reality and the mystery of awareness, the result feels almost dreamlike. Not because science has proven mystical conclusions, but because human understanding has not yet reached the bottom of either mystery, which leads naturally toward one final philosophical possibility, perhaps the oldest and strangest of all. What if consciousness is not something produced by reality, but something woven into reality from the very beginning? Not thoughts or personalities hidden inside atoms, not tiny minds floating through electrons, but perhaps some faint primitive form of inner existence embedded deeply within the fabric of nature itself. A possibility that many philosophers once dismissed entirely, but which has quietly begun returning to scientific discussion in recent years. For centuries, most science has operated from a simple assumption: matter comes first, consciousness comes later. In this view, the universe existed for billions of years as entirely unconscious matter drifting through space. Then eventually, through chemistry, evolution, and biological complexity, consciousness emerged inside certain living brains. This remains the dominant scientific perspective today, and for many researchers, it may ultimately prove correct. But there is another possibility, older, stranger, and increasingly difficult for some philosophers to dismiss completely. What if consciousness is not something produced entirely from non-conscious matter? What if awareness, in some extremely faint and primitive form, has always been part of reality itself? This idea appears in many different philosophical traditions, but one modern version is often called panpsychism. The word itself can sound intimidating and slightly robotic when spoken aloud, so it helps to approach the idea gently, rather than technically. Panpsychism does not claim that rocks hold conversations, or that electrons secretly write poetry somewhere beneath the fabric of space. Instead, the idea is subtler. It suggests that consciousness may not suddenly appear from completely unconscious ingredients, like magic emerging from nowhere. Perhaps instead, the basic building blocks of reality already contain some incredibly simple, proto-experiential aspect, something unimaginably faint compared to human awareness, yet not entirely devoid of inner existence either. In other words, consciousness may be fundamental rather than accidental. Not necessarily complex consciousness, not thoughts, not language, not identity, but perhaps some primitive interior quality woven quietly into the fabric of nature itself. At first, this idea sounds deeply strange, but then again, so does consciousness itself. After all, modern materialism already asks us to believe something equally astonishing. It asks us to believe that entirely unconscious particles somehow combine in sufficiently complicated arrangements until suddenly subjective experience appears. At some point, matter begins feeling like something from the inside, and despite extraordinary advances in neuroscience, nobody yet fully understands how that transition occurs. Panpsychism attempts to soften that leap slightly. Rather than consciousness appearing abruptly from complete absence, perhaps increasingly complex forms of awareness emerge from simpler forms already embedded within reality. Like tiny sparks gradually combining into larger flames. Of course, this immediately creates difficult questions too. If primitive awareness exists everywhere, why does a human feel richly conscious while a grain of sand does not? Panpsychists usually answer that consciousness depends not merely on ingredients, but on organization and integration. A single water molecule does not create an ocean wave, but enormous numbers interacting dynamically together can generate something vastly more complex. Likewise, tiny proto-experiential properties, if they exist at all, may only produce full consciousness when arranged within highly integrated systems like brains. Still speculative, still controversial, but philosophically intriguing enough that some modern thinkers take it seriously. Partly because the alternatives remain mysterious too. Another perspective goes even further. Certain forms of idealism propose that consciousness may not merely be part of reality, but the foundation beneath reality itself. In this view, matter does not generate mind. Mind generates the experienced world. Again, this idea must be handled carefully, because it is easy to drift into exaggerated mystical claims unsupported by science. Most neuroscientists would strongly reject the idea that the physical universe exists only inside human imagination. And clearly, reality behaves independently of personal wishes much of the time. Gravity remains stubbornly real whether or not you believe in it while tripping over stairs half asleep at 2 a.m. But philosophical idealism raises a subtler point. Everything you have ever known about reality arrives through consciousness. Every star, every equation, every memory, every scientific instrument reading, all of it appears within awareness. You never step outside consciousness to compare it directly against some completely separate objective world. Experience is always mediated through perception. This does not prove idealism correct, but it reveals something important. Consciousness is not just another object inside reality, like a chair or a cloud. It is the condition through which reality becomes known at all. And perhaps that is why consciousness continues resisting complete explanation so stubbornly. Some philosophers now argue that the deepest problem may lie in how humans divide reality conceptually in the first place. Matter on one side, mind on the other, object versus subject, physical versus experiential. But perhaps these divisions reflect limitations in human categories rather than ultimate truths about existence. Maybe matter and consciousness are not entirely separate substances. Maybe they are two aspects of one deeper underlying reality humans do not yet fully understand, like wave and particle descriptions in quantum physics, revealing different aspects of the same underlying phenomenon depending on perspective. This possibility has emotional consequences too. If consciousness is deeply woven into reality somehow, then awareness becomes less like an isolated accident appearing briefly in a cold, indifferent cosmos, and more like an expression of something already latent within the universe itself. Not necessarily a comforting universe, not necessarily a purposeful one, but perhaps a universe less alien to consciousness than strict mechanistic materialism once imagined. And interestingly, modern physics itself has gradually softened some older notions of matter as perfectly solid, lifeless substance. Atoms are mostly empty space structured by fields and interactions. Quantum systems behave relationally. Energy and matter transform into one another. Space and time bend dynamically rather than remaining rigid backgrounds. Reality increasingly appears less like tiny billiard balls colliding mechanically through empty space, and more like an intricate web of relationships, processes, probabilities, and patterns. Some thinkers wonder whether consciousness may belong somewhere naturally within that deeper picture. Others remain unconvinced, and perhaps wisely so. Because beautiful philosophical ideas are not automatically true, science advances through evidence, prediction, and careful testing, not emotional appeal alone. At the moment, there is still no scientific consensus that consciousness is fundamental to reality. The mystery remains open, and maybe that openness itself matters. Human beings often crave final certainty, a definitive answer, a completed explanation neatly wrapping the universe into understandable form. But consciousness continues resisting closure. The more carefully we examine it, the more it seems to dissolve into deeper questions beneath the surface. Questions about self, reality, time, experience, existence itself. And perhaps there is something quietly humbling about that. The universe produced creatures capable of mapping galaxies, splitting atoms, decoding genetics, and landing instruments on distant worlds. Yet those same creatures still cannot fully explain the simple fact that experience exists at all, that colours feel like colours, that music can move us emotionally, that loneliness hurts, that beauty sometimes arrives suddenly on ordinary evenings for reasons impossible to explain logically. Somewhere inside this vast universe, matter became capable of inner life. Whether consciousness emerged entirely from biology, or reflects something more fundamental woven into reality itself, remains unknown. But either possibility is astonishing, and as these thoughts drift softly through the mind, another mystery begins quietly appearing nearby. Because even if consciousness is fundamental, even if awareness flows continuously beneath changing experience, the self you call you may still be far less fixed than it seems. Time moves strangely through consciousness. Memories fade and reform. Identity shifts gradually across years. And the mind continuously stitches together the feeling of continuity from moments already disappearing into the past. If you close your eyes for a moment and think back to your childhood, the memory probably feels strangely immediate. Perhaps you remember the smell of a classroom after rain, the sound of dishes in the kitchen late at night, a bicycle leaning beside a wall during summer. Maybe there is a specific afternoon that still glows softly in your mind for reasons you cannot fully explain, and yet the person who lived those moments no longer fully exists. Your body has changed. Your brain has changed. Most of the cells present in your childhood body have long since been replaced through ordinary biological processes. Memories have shifted and reconstructed themselves repeatedly across time. Even your personality has likely drifted slowly through experiences, relationships, griefs, joys, failures, and years. And still, despite all that change, you somehow feel like the same person. Why? This question sits quietly beneath ordinary consciousness almost every day without attracting much attention. The continuity of self feels so natural that we rarely stop to examine how strange it actually is. You wake each morning assuming the you who opens their eyes today is fundamentally connected to the you who fell asleep last night. But consciousness does not arrive as one perfectly frozen object moving unchanged through time. It flows, and the brain works continuously to maintain the feeling of continuity within that flow. Some philosophers and psychologists describe conscious experience using a phrase called the specious present. The name sounds more complicated than the idea itself. It simply means that the present moment you experience is not an infinitely thin mathematical instant. Instead, consciousness holds together a small flowing window of time containing traces of the immediate past blending gently into the unfolding present. When you hear music, for example, you do not experience isolated individual notes separately. The brain stitches them together into melody. A sentence only makes sense because your consciousness retains the beginning long enough for the ending to arrive. Even your sense of motion depends on continuity. If awareness existed only as disconnected frozen instants, reality might feel shattered into isolated flashes rather than smooth flowing experience. The brain quietly performs an extraordinary act of temporal weaving every moment of your life, and usually it does this so seamlessly that you never notice. But certain experiences reveal how flexible and fragile this construction can become. Think about dreams again. Inside dreams, time behaves strangely. Entire narratives unfold within minutes. You may experience long journeys, conversations, or emotional events despite only brief periods passing physically during sleep. Meditation can alter time differently. Deep stillness sometimes expands moments into spacious awareness, where ordinary clock time feels distant and less important. Fear changes time too. A sudden accident may feel stretched into slow motion. Tiny details become vividly memorable because the brain enters heightened states of attention and emotional encoding. Boredom does the opposite. Minutes drag heavily through waiting rooms, traffic jams, or restless, sleepless nights, staring at the ceiling while thoughts circle endlessly through unfinished worries. Time, as consciously experienced, is deeply psychological, not entirely invented, but actively shaped by attention, memory, emotion, and awareness. And perhaps the self is constructed similarly. Your identity depends heavily on memory linking experiences together across time. You remember your past, anticipate your future, and weave both into an ongoing narrative called my life. But memory itself is not stable. Neuroscience increasingly shows that memories are reconstructive rather than perfectly preserved recordings. Each time you recall an event, the brain partially rebuilds it. Details shift subtly. Emotions reshape interpretation. Certain moments sharpen while others fade almost completely. In some sense, your remembered self is continuously rewritten. This realization unsettled many philosophers long before modern neuroscience existed. Centuries ago, thinkers began asking variations of the same haunting question. If every aspect of you changes gradually over time, what exactly remains the same? The ancient ship of Theseus thought experiment explored this beautifully. Imagine a wooden ship repaired piece by piece over many years until every original plank has eventually been replaced. Is it still the same ship? Human identity may involve a similar paradox. Your body changes, your memories evolve, your beliefs transform, and yet consciousness somehow maintains the feeling of continuity through all of it. Perhaps identity functions less like a fixed object and more like a stable pattern persisting through change. Like a river, The water molecules continuously move and change, yet the river still retains recognizable form over time. Or like a flame, the fuel constantly transforms, but the flame appears continuous. Maybe the self resembles that kind of dynamic continuity more than a permanent unchanging entity. And strangely enough, this idea can feel both unsettling and comforting at once. Unsettling because the solid, permanent self we instinctively imagine may not exist exactly as we think. Comforting because consciousness becomes less trapped by rigid identity. You're not a frozen object, you're an unfolding process, a living continuity moving through time. Modern neuroscience supports parts of this perspective surprisingly well. The brain continuously updates its internal self-model, using new experiences, memories, bodily sensations, and predictions. Identity is not stored in one fixed location. It emerges dynamically through ongoing activity and integration. Even personality can shift dramatically after injury, trauma, illness, aging, or profound life experience. And yet throughout these changes, awareness itself continues flowing. A child becomes an adult becomes elderly. Memories gather quietly like leaves, accumulating through seasons. Some disappear entirely, others remain strangely vivid for decades. But consciousness keeps moving forward through the changing landscape of identity. Perhaps this is why old photographs sometimes feel emotionally strange. You recognize the child smiling in the image as yourself, yet also not entirely yourself anymore, like meeting an earlier version of consciousness preserved briefly in time, a different arrangement of memories, hopes, fears, and perceptions. And one day, the person you are tonight may feel similarly distant to whoever you become years from now. The self drifts gradually across time while maintaining enough continuity to preserve the feeling of personal identity. And maybe this gentle instability is not a flaw in consciousness. Maybe it is part of what allows growth, adaptation, creativity, and emotional resilience to exist at all. A perfectly rigid self could never truly change, could never learn, could never heal. Consciousness remains alive partly because it flows, and perhaps that flow connects quietly to something much larger than individual human identity alone. Because when you step back far enough, your awareness becomes part of an extraordinary cosmic story stretching across billions of years. Hydrogen becoming stars, stars becoming planets, planets becoming life, life becoming minds capable of memory, reflection, imagination, and wonder. Matter slowly awakening into experience, and somewhere within that immense unfolding process, your consciousness exists tonight, briefly carrying the universe inside awareness before drifting once more into silence and sleep. For most of cosmic history, there was no music. Not because sound could not exist physically, but because nothing existed to hear it. Stars burned silently through darkness. Galaxies drifted across expanding space. Black holes swallowed light beyond distant horizons. Entire worlds formed, froze, shattered, and disappeared unnoticed for billions of years. The universe was active, beautiful perhaps, but not yet experienced. Then slowly, something changed. On at least one small planet orbiting an ordinary star, chemistry became biology. Biology became perception. Perception became memory. Memory became imagination. And eventually the universe produced creatures capable of wondering what consciousness is. That fact remains astonishing no matter how often we repeat it. Hydrogen formed in the early universe nearly 14 billion years ago. Inside stars, heavier elements slowly emerged through immense pressure and heat. Exploding supernovas scattered those elements across space like cosmic seeds, drifting through darkness. From those ancient materials came oceans. From oceans came cells. From cells came nervous systems. And from nervous systems came awareness. Somewhere along that unimaginable chain of transformation, matter learned not only to exist, but to experience existence. Tonight, your consciousness carries the result of that entire cosmic history inside it. The iron in your blood once existed inside ancient stars. The calcium in your bones drifted through galaxies long before Earth formed. Even the oxygen moving quietly through your lungs tonight was forged in stellar furnaces billions of years before human language or memory ever appeared. You are, in a deeply literal sense, made from ancient cosmic history. And yet the most extraordinary thing about you may not be the atoms themselves, but the fact those atoms became aware. The universe somehow developed an interior, a way of feeling itself from within. Perhaps that sounds poetic rather than scientific, but in another sense it is simply true. Conscious organisms are part of the universe. Human thoughts emerge from physical processes unfolding within reality itself. When you look at the stars, the cosmos is not being observed from outside. It is being observed from within its own unfolding existence, matter reflecting upon matter, awareness examining awareness. And despite all our scientific progress, we still do not fully understand how this became possible. Neuroscience maps networks and patterns inside the brain with astonishing precision. Physics describes the behavior of matter and energy across scales ranging from subatomic particles to galactic clusters. Evolution explains how increasingly complex organisms emerge through natural selection across immense spans of time. And still, consciousness remains partially hidden. Not invisible exactly, but intimate. Difficult to isolate because every attempt to study it already occurs inside experience itself. Perhaps that is why consciousness feels both scientifically fascinating and emotionally personal at the same time. This mystery is not happening somewhere far away in distant galaxies or abstract equations. It is happening right now, in every thought you have ever experienced, every memory, every dream, every quiet feeling arriving unexpectedly during lonely evenings or peaceful mornings. And maybe there is something strangely comforting about the fact that science has not fully solved this mystery yet. Human beings sometimes imagine knowledge as a process of removing wonder from the universe. But often the opposite happens. The deeper we investigate reality, the stranger and more beautiful it becomes. Atoms become quantum fields. Time bends near gravity. Space expands. Matter organizes itself into living systems capable of love, grief, imagination, and self-awareness. And consciousness continues shimmering quietly at the center of it all like candlelight inside a dark room. Some scientists believe consciousness will eventually be explained entirely through biological and computational principles. Others suspect reality may contain deeper layers still waiting to be understood. Perhaps awareness emerges naturally from sufficient complexity. Perhaps consciousness reflects fundamental properties woven into existence itself. Perhaps both ideas contain fragments of truth humans have not yet learned how to combine. At the moment, nobody truly knows, and that uncertainty is important, because science works best when it remains honest about the boundaries of understanding. There is humility in admitting that the most familiar thing in human life, conscious experience itself, remains partly mysterious. But perhaps mystery is not failure. Perhaps mystery is simply what honest knowledge looks like near the edge of understanding. Imagine standing beside the ocean at night. Moonlight touches only the surface while immense depths remain hidden below. You do not conclude the ocean is unreal because you cannot see the bottom completely. You simply recognize that reality extends further than your current vision reaches. Consciousness may be similar. We've illuminated remarkable portions of the mystery already. We understand neurons, sleep, memory, attention, prediction, emotion, and perception far better than previous generations ever could. And yet beneath those discoveries, deeper questions continue waiting quietly. Why does experience exist at all? Why does reality contain an inner dimension? Why should the universe be capable not only of structure and motion, but also of beauty, sadness, longing, wonder, and awareness? Perhaps one day humanity will answer these questions more fully. Or perhaps consciousness will always remain partly mysterious, because we ourselves are made from the very phenomenon we're trying to understand. A wave attempting to comprehend the ocean completely. And maybe that is all right, because even without final answers, there is something profoundly beautiful about the journey itself. The universe spent billions of years evolving stars, planets, oceans, cells, nervous systems, and minds capable of asking questions beneath quiet nighttime skies. And tonight, after all those billions of years of cosmic unfolding, your consciousness exists briefly within that vast story. Listening, wondering, experiencing. Soon you may drift towards sleep again. Thoughts will loosen softly. The boundaries of waking awareness will blur. Dreams may arrive quietly like distant weather moving across the landscape of the mind. And somewhere beyond those dreams, the ancient universe will continue expanding silently through darkness as it always has. Galaxies drifting farther apart, stars continuing to burn, planets turning slowly through space. But now, unlike the early universe, there are conscious beings here to notice it, to feel it, to wonder about it. And perhaps, in some small but meaningful sense, that changes the story of the cosmos forever. Because the universe is no longer entirely silent. It has begun speaking softly through living minds. And one of those minds, for this brief moment tonight, has been yours. So wherever you are listening from, whether the night around you feels peaceful or restless, crowded or quiet, thank you for spending this little stretch of consciousness here together. If your eyes are growing heavy now, that's perfectly all right. Let the thoughts drift. Let the questions remain open. Not every mystery must be solved immediately to be meaningful. Sometimes it's enough simply to sit beside the mystery for a while, listening quietly as the universe continues unfolding around and within us all. And so, we've reached the end of tonight's exploration. Whether your eyes are still open or you're already floating somewhere between waking and dreaming, thank you for being part of this little journey. If you'd like to join me again for more gentle wanderings, you're always welcome to subscribe or share this with someone who could use a peaceful pause. Time has a way of slipping through our fingers, but here, in this quiet moment, it's just you and the soft hush of rest. Sleep peacefully wherever and whenever you may be.